Yep, thanks for the introduction. My name is Volodymyr, full name, people call me Vlad. And I'm a PhD student at the University of Manitoba. And today I'm here to talk about the work I did as an intern at Autodesk Research one of the previous summers. And yeah, it's called Maestro, designing a system for real-time orchestration of 3D modeling workshops. So children often learn 3D modeling in group workshops. And they often have structured in the way that you have an instructor who is guiding the children through a step-by-step tutorial, and children just repeat instructions step by step. However, prior work tells us that facilitating these things as an instructor is very challenging because, first of all, you need to be aware of what each student is doing so that you know who is falling behind, who is following the instructions, and when it's safe to move to the next step. You also need to provide assistance to those who struggle, who cannot keep up with the pace or have problems. And also you need to manage all the social interaction that happens between kids and between yourself as an instructor. And these are like very generic challenges that can apply to any type of workshop, but they're also domain-specific challenges. For example, in 3D workshop, 3D modeling workshops, it's very common for for children who just start, to develop something from the same angle, same perspective, and never change their view because they're not used to being in 3D. And this results in their models seem to be okay, but in fact they're not really connected at all, which could be a problem when you try to 3D print them. So in this work we present Maestro, which is a system that does some real-time analysis of student command data to help instructors facilitate these workshops by detecting common challenges. There are other systems in both research and on the market that look into this one-to-many tutoring assistance. For example, the system that is on the market is Net Support School. It's a system that allows you as an instructor to see view of each student's screen and to do some generic interventions, such as, for example, taking control of a user's input. Our approach dives into depth of a specific domain, in our case 3D modeling. And this allows us to use domain-specific knowledge to help instructors detect potential problems that are common in this domain early in the stage of their development. There's also been research on one-to-many remote tutoring interfaces, and probably many of you know the paper called Codopticon and the system called Codopticon. And our approach is a bit different because we focus on in-person type of workshops where there's lots of social interaction, and we aim to augment this interaction, to extend this instructor's reach while not replacing this interaction with the system. We also look at different domain because in 3D modeling we don't really have an objective identifier of an error such as compilation error. Overall, we do the following contributions. First, we present an idea of data-driven, real-time assistance for conducting in-person 3D modeling workshops. Oh, that's a mouthful. We also present design and implementation of Maestro. And finally, we present an evaluation of Maestro in a workshop with instructor and 13 children. So without further ado, let's jump into the system. So Maestro works with Tinkercad. Tinkercad, for those who don't know, is an online tool that allows you to do some basic 3D modeling, and it's very accessible, and it's open, you can join, you can try it for free, and that makes it very popular for these kinds of workshops to introduce children into 3D modeling. And when designing Maestro, we consulted prior work, and we also consulted two experienced workshop facilitators from local makerspaces, and we arrived at the following set of design goals. First, we wanted to provide a glanceable overview of students' progress. We also wanted to draw the instructor's attention to relevant activity patterns, which we know from prior work and from our interviews that these patterns might indicate potential problems or good practice. We also wanted to augment instructors' capabilities with quick interventions that they can set to students. And last but not least, we wanted to leave the initiative to the instructor and make the instructor the one who decides what to do, what intervention to send, and what to say to student. So the way Maestro works is it looks at the command logs from students in real time, and it displays instructor a dashboard where each student is represented by a widget. And on this widget, the instructor sees a live view of the student's workspace and also a real-time command activity from the student. So after consulting prior work and the workshop facilitators, we decided to split the whole command activity into 3 timelines. The top one shows the object modification commands, the middle one shows the read navigation commands, and the bottommost shows the undo and erase events. Further, Maestro also uses heuristics to try to analyze these logs in real time, and it looks for activity patterns, which we know from prior work and from interviews that these activity patterns indicate either good practice or potential problem. And then Maestro recommends the instructor to send quick interventions based on these heuristics that could either encourage the student for a good job or they could help the instructor prevent potential error. And let me just guide you through a couple of examples of these heuristics. First is the read Navigational Monitor. So, as I mentioned before, it's very common for children in these workshops to never change their view and do everything from the same angle, which causes problems. And what Maestro does is, when it detects that a student has been working for a while without any navigation, it highlights it on the dashboard, on the command log, and also it recommends the instructor an intervention. And if an instructor accepts this intervention by clicking on it, it shows a message on the student's screen reminding the student to look at their model from different angles to make sure that everything is okay. Another example of this heuristics is follow-along detection. So as I mentioned before, these workshops often structured in a follow-along way, that you have a tutorial and instructors going step by step, waiting for students to complete the previous step before moving to the next one. And what Maestro does is, when it detects that more than half of a class repeated the command after the instructor, it switches to a follow-along mode. And in this follow-along mode, the instructor sees a real-time indication in a very glanceable way of who has followed the command and who has not. More than, Maestro also keeps track of who is following the instructions well and recommends the instructor to send the students a thumbs-up intervention. And this is meant to encourage students, and the way it shows up is as a flashing thumbs-up message on the screen like, yay, you did well. In addition to these heuristics, Maestro also allows the instructor to send manual intervention to students, such as the ability to point to a location on the student's screen and also to ask one student to go and help another student. We evaluated Maestro in a workshop with 13 children and an experienced workshop facilitator that we hired from local makerspace. And our goal for this evaluation was twofold. First, we wanted to get feedback on this whole idea of augmenting in-person workshop with data-driven assistance. And also, we wanted to collect data to check our heuristics, because to see if they're performing whatever we intended them to do. And the first type of data we collected was command activity. So this image depicts all the command activation that happened during the workshop from instructor and the students. And the way we use this very colorful and nice graph is to check our heuristics, as I mentioned. For example, the way we checked it is, let's talk about the follow-along heuristic. It was pretty much probably the most complex one that we had. And the way it worked, again, is it activated the follow-along mode if at least half of the classroom followed the instruction from the facilitator. And inspecting this heuristic against the data showed that it was quite successful. Like, it detected many scenarios when students were supposed to follow the instructor. But there were also some cases where it did not detect, and that was something we were looking for. And one of these cases, this is the image. So this happened for the creators command. And here you can see a zoom in on a specific area through the entire workshop, where you see like a cluster of activation of this command. And here you can see also the instructor's command, extract demonstration, is marked by the vertical line, and all the other dots are representing the students' invocations of this command. And we saw that our heuristic did not work here because most of the students activated the command before the instructor. And we were curious why it happened. We looked into the video of the workshop, and we saw that this happened because the instructor first asked the students verbally to complete the command, and after like 10 seconds, she repeated it herself. And of course, this suggests the direct improvement for our heuristics, just to include also those command activations from students that happened before the instructor's demonstration. In addition to collecting and looking in the log data, we also conducted a semi-structured interview with the instructor. And in this interview, we asked her to compare her experience of running this workshop with Maestro to her prior experiences of running the same kinds of workshops without the system. And one of the things she mentioned was that follow-along detection helped her to pace the workshop. Specifically, she said that, I really like the function where I could see if they follow my direction. I thought that was great. The screens lighten up green and red. It just draw my attention to a really quick glimpse sort of way who's with me and who's not. I don't have to rely on the students to let me know if they did not get the step, and then I won't speed ahead to the next thing. So in this quote, she referred to the first half of the workshop in where she was doing follow-on tutorial with students, and this quote and observation suggests that having this glanceable real-time feedback could really increase the instructor's confidence into ability that knowledge that it's safe to move to the next step and that to not leave students behind. Another piece of feedback we received that she felt like Maestro extended her reach to students. Specifically, she said that instead of me being like, hey, just a second, and coming over to the other student, I could just use point-to intervention, and the student would see the command's location on their screen. This way, I can stay with my really high-need kids and do my quick interventions with the system for common problems. This finding suggests that there is a room for improvement in helping the instructor to reach the most students, especially when they have these very common, easy-to-fix problems, such as not being able to find a command on the interface. And the same point is also demonstrated by a different quote from a different angle. And here the instructor said that a lot of times students think they follow the instruction, but they are not sure if they did. So giving them like quick thumbs up, like you got it, is good. And then they know that they could wait for the next instruction if they don't know if they got it right. I just see it as a potential way to say, you're good, wait. This quote suggests that there's also room for improvement in terms of helping the instructor to provide feedback to students on their work. And together, these findings, they suggest the value of these quick and pre-authored interventions. That would it be for giving feedback to students, or would it be for helping them with potential problems? Another interesting finding was that the instructor felt that Maestro gave her objective data that could help her avoid biased view on her students. Specifically, she said that it is very important for us teachers to be able to see where our students' strengths are, and a lot of time it's hard to see it because we have jagged ideas about certain students if they cause us a lot of grief or whatever. And she felt that this quote suggests that this objective data could help us remove some of this bias from the judgment of the student from the instructor's perspective. Finally, we also found that there could be a big challenge with splitting attention during these workshops. Specifically, the instructor said that paying attention to both the classroom and the tool was really hard. I felt really torn, and my inclination was to just pay attention to the children and the classroom. But I also want to use the tool because I see its value. And this suggests that high cognitive load could be one of the big challenges for this kind of real-time, in-person workshop assistance, and that future work should investigate the ways we can reduce this cognitive load. Overall, our findings suggest that the approach of using real data and analyzing it in real time for assisting in-person workshops is quite promising. And we also uncovered some directions for future work. For example, one direction is using more advanced learning modeling techniques. Because our approach used quite basic heuristics, which were based on the command sequences, which worked pretty good. But one can imagine that a richer model of a student could help making more accurate predictions and more accurate suggestions. And this more accurate suggestion mechanism could actually reduce the cognitive load, which I've been talking about. Another interesting direction to explore is allowing students to interact with systems like Maestro. Because one could imagine that it could be interesting to see what happens if students also can use this kind of system to ask the instructor for help or for feedback directly. And finally, it will be really interesting to investigate how this idea generalizes to a larger context, because you can imagine if workshop is quite big, there could be more than one instructors, or there can be instructor and multiple TAs, and it would be interesting to see how this would scale. That's it. Thank you for your attention, and let me know if you have questions.
So while people are thinking of asking a question, oh, okay, we have one person.
Yeah, I'm Takegurashi from University of Tokyo. Do you support interaction between students?
So we built something. We didn't really support it through this system. We did something to ask instructor to ask one student to go help another student. But our observation, so we built this kind of intervention in there. But it wasn't honestly used in the workshop, and when we asked instructor why, she told us that she still prefers to do these things in person, and also in this workshop it honestly didn't really make sense for her because it was her first time with this audience, and she told us that if she were more familiar with those students, she would know who to send to whom, who is the fast learner who can be struggling. And so maybe in future stages of this, when she's more familiar with classroom, she could use more of that feature, but we didn't observe that use right now.
Thank you.
Yeah.
So I have one question. I know that you've been thinking about supporting new learning styles and perhaps new classroom environments. What are your thoughts in terms of extending the systems to support collaborative projects where you might have groups of students learning or working on projects? Some of them might be in the classroom, some of them might be remote.
You mean collaborative projects when multiple students work on the
Yes.
same type of, basically on the same problem?
Yes.
Yeah, this could be a very interesting direction to explore. The initial assumption that if you just track the basically number of machines, let's say, it will just decrease out of the classroom. But if we want to look past that, for example, you can also look at the contribution of each student into the project. That could get very tricky. But that's a very interesting direction to explore, yeah.
Cool. Okay, let's